Alright, so we're going to be setting up a triple integral. So here's the first boundary, which is just completely wrong. Alright. Alright, so...
Why don't you write the equation first?
That's for wimps.
9 minus x squared minus y squared.
Squared. It's actually x squared plus y squared plus z squared.
All rooted.
All rooted to the ground.
And dz, dy, dx.
Dz, dy, dx. 0 to the square root of 9 minus x squared. And then 0 to 3.
Yep.
Now these radicals look super scary, but if you realize it's just an upside down dome, which can be properly described as this. And we'll use this to help us in the future. But Jack over here thinks it's a great idea to use a cylindrical coordinate system. So we're going to see
no such thing, but we're going to see how it goes. Just
we're going to see how this dumpster fire heads.
Yeah.
I'll just be judging and watching.
It's fair. All right. So for cylindrical, you can just get your little basic facts down. X is our cosine theta.
Hey, can you prove that for me, please?
No. Z is Z. Cool. And we also know the little handy thing that x squared plus y squared is equal to r squared. So all of those are going to help us. So we can let that, if we want to try to do this way.
You want to get super yellow in there?
Oh yeah, let's get super yellow. Okay, so this...
Yeah, that's not super yellow.
That's not super yellow.
That's fake yellow.
Yeah, okay, this is... There's super yellow.
Yeah.
Okay. So 0 to 3, 0 to... What is this? Actually, let's not even worry about our bounds yet, because we're going to need
Let's use the clock.
Yeah, you're
not
right.
ruin the perfect glass screen that I just spent 30 seconds cleaning.
Okay. So this is going to turn into r squared plus z squared, and their dz, dy, dx is going to change to an r, dr, dz, d theta.
Remember, when you switch to cylindrical, you have to add the r in.
Yeah, that is a fact. All right, so how do we want to have our r go? I mean,
R is
0 to 3.
0 to 3. It's just 0 to 3. So you need to move that 3 all the way in.
0 to 3.
The outer integral 3 on the top bound is incorrect.
Yeah, I know. We still need to change that. I just was starting to copy that one, and then I'm like, oh, we got to do our bound.
To see what we're actually doing with this little spherical thing, which will help you understand it in the future, is that would be our z. So, yeah.
Yeah, the r is only acting on this xy plane, so the r is still going to go out from the center to 3 everywhere around. So that's still good. The z term right here in the middle is going to be a pain. Mostly because...
Just set it up.
Is it the negative one?
It's negative, yeah. It's negative 9 minus...
Z squared?
Yeah.
Yeah, because the r is 3.
The r is the first one. It's dz, dr, right?
Yeah, no, I know. The r is the first one. So we're describing our second one.
How could z be in itself?
Long story short, cylindrical coordinates is a dumpster fire.
No. We have to set this up. We'll set it up.
I mean,
yeah, it was the first integral. We switched it. It was
9 minus
No,
the
you
squared
need
positive.
to flip these integrals.
Oh.
Yeah. It's not solvable currently.
Yes, you do have a point there.
Because you're stuck with z's.
Alright. So this is actually going to be...
Negative.
So this is our r?
Yeah.
Our r goes from...
Yeah, because after we integrate, it'll turn into a z, then we integrate the z, and then we integrate the r.
No, I know, but how does this describe our r? It looks like our r goes 0 to 3.
No. It's 0 to... It's... Keep going.
Alright. And then, what, our theta is 0 to 2 pi?
Yeah, because it just goes all around the circle.
Cool.
So, if you look at this drawing, you see why this is a hot mess, because the r is actually transcribing to the x, or the y. Yeah, so essentially, see how this goes down, and it's just a straight line? This turns it into a kind of a mess of an equation. So in this area, it's actually a Cartesian plane that we're forcing, which is why we get these weird radicals. Which is why, once we've set this up, we realize this turns into a dumpster fire.
It's going to be a U sub.
You U sub it, and then you're left with radicals, and then eventually you might get something that's useful, so we're just going to
pretend that didn't happen.
Yeah, we're just going to pretend this was fine. This is right.
Let's do this the handy way really quick of spherical coordinates while we still can.
Yeah.
We've already seen what the picture looks like.
Okay, so there we go. I'll do that.
Let's just, here, I'll write down some facts, like our dz, dy, dx is going to be equivalent to rho squared sine phi d rho d phi d theta.
If you recall from a lecture that you didn't pay attention to, you'll realize that this actually just turns into rho. So we have rho times rho squared. You gotta have that little tail, you gotta have to be fancy about that. Sine phi delta rho delta phi delta theta. And if you look at these coordinates, so this just goes 0 to 3 since it's the rho.
Yeah, the rho.
This goes 0 to 2 pi because let's recreate the dome here. So this is the radius here. However, we get to the top and we want to do kind of 2 pi. So we kind of take it down and create like a little flap. And that flap goes around and just cleans the rest of the dome, and that's how we get all of our area.
Do not know what that explanation means, but yes.
This is fine. It's kind of like a turbine engine. It grinds through. It's fine.
Yeah. Positive z, down to xy, pi over 2.
Excuse me.
And theta is 2 pi all around.
There we go. All right, so quick integral delta phi turns into phi 4 over 4 sine phi. That's a phi. That's a phi. It's fine. 0 to 3, which turns into 81 over 4 sine of phi. So once we have that, I'm going to erase and get some more real estate here. We've knocked out the first integral, so we're going to actually rewrite that as...
maybe just to erase that third one.
Erase this little integral.
Okay, so then we got the 81...
81 over 4 sine phi.
Yeah.
Delta theta.
Cool.
All right, so this turns into 81, negative 81 over 4, because the integral of sine theta is negative cosine phi. I said sine phi. Minus 81
over
4 cosine. Actually, we're plugging this in right now, saving some time. This is pi over 2. The boundary was 0 to pi over 2 minus cosine of 0, which is already a negative, so this becomes a plus. This cancels out because it's a 0, so we're left with an 81 over 4 of 1, because this becomes equals to 1.
Well, just the cosine part.
Yeah, just this cosine part. And that becomes an integral of 0 to 2 pi of
81 over 4
delta theta. And that just turns into 81 pi over 2, because the 0 cancels out.
Sick 2.
That's it. There we go, and that's our answer. Pretty simple and spherical. Important thing to note, don't be scared when you look at those radicals. They're not as bad as everyone says.